Okay, so hello everyone. This is group 17, and we are going to present our NAV language. So yeah, Atharva, can you share your screen?
Yeah.
Okay, so yeah, next slide, please. So yeah, we chose to name our language as NAV and AAV, which is the initial for each and every team member's name. So yeah, we this NAV language is a much more versatile language and it has a user-friendly syntax. We decided to like draw inspiration from Java and Python. So it also consists of familiar code structures like main method. Then inside that there will be multiple declarations and commands and print statements. This language also supports primitive data types like primitive types like Boolean operators, which consists of true and false, numeric operators, which consists of addition, subtraction, division, and multiplication, uh, strings, along with rich operators like conditional looping constructs with complex logic efficiently. Yeah. Next slide, please. Okay, so this is the structure of our language. So first is the source code, where our program would be written as with .nav as the extension, and then it is passed to the tokenizer, which is written in Python, and then the tokenized output from tokenizer is passed to the parser, which is written in Prolog, and then it is passed to the evaluator, which is also written in Python, and then the final output is returned by the evaluator. Okay, so next, Nisha will be speaking on the grammar.
Hi, so I will be explaining the grammar which we have implemented. And for the block, we have the main block which is divided into three parts: declarations, commands, and print. And the declaration rules, we can see that there are two rules basically for declaration. The first one is for multiple declaration, and the second one is for the single declaration. And then coming to the rules, it has variable declaration rule or instant declaration rule. And the variable declaration would come into picture when we have to assign some value. So then we'll be using the variable declaration. And if we do not have to assign any value, then the instant declaration rule would be used. And for the print statement, we'll be printing the value which could be a Boolean string or of num type. And coming to the command rules, uh, we have again like multiple commands and the single commands. Now coming to the next slide. So for the command rules, we have rules here for the expression, Boolean, and the for loop, range loop, and all the conditions and looping structures. Now later the looping structures would be explained by Ansh. Ansh, over to you.
Hello, I'm Ansh Sharma. So I'll be explaining these expression rules first. This slide actually presents the arithmetic expression rules for arithmetic expression. So here you can see that you can define arithmetic expression as a single term or a term with arithmetic operator and then another arithmetic expression. Now this higher precedence here is actually if you see in the arithmetic operator rules, the division and multiplication, according to this higher precedence, are of the same level, and plus and minus, addition and subtraction are of the same level after multiplication and division. If we look at the term rules over here, so term can be a factor and fact or a factor with arithmetic operator and another term. So factor rules, if you see, factor can be a value or an arithmetic expression in itself. So basically, this allows us for having multiple values in the arithmetic expression. So type rule defines the types that we allow in our language. Number is basically num, which allows both integer and float values. Then there's Boolean, bool, which is capital T or capital F. And then there is string. ID is identifier. Identifier basically the names you give to your variables. Next slide, please. Yeah, so if we talk about values, values can be number, string, boolean, or identifiers. So number, these are basically the definitions for different types. Number can be, again, as I said, integer or float. String can be, again, a string. Boolean is capital T and capital F. Identifier can be a single character also, and can be multiple characters, basically it's multiple characters together. So that's the definition for identifier. Assignment operator is equals, this is the grammar for assignment operator, and then there's grammar for comparison operators. These are the comparison operators we allow. And again, Boolean operators we allow in our language are and, or, and not. Basic uh, Now, definition for condition. Condition can be a value comparison operator or value, or it can be a simple Boolean expression. Now, Boolean expression uses, it can be either a single Boolean value, or it can be a Boolean value operator or value. It can be a condition, or condition, Boolean operator and condition, condition, Boolean operator or value, Boolean operator condition. Basically, basic Boolean expressions that are used. Next slide, please. So this is about execution of the whole program. So of our whole language. So we have an executor.py module which combines these three modules, which is lexer or tokenization, parsing, and evaluation. This combines these three modules, and we basically have to pass on the command terminal our executor file. This is written in Python, so it's executor.py, and along with it we have to provide the file path of our source code as an argument in the command terminal. So the results would be the output of the program you have written in .NAV. Next slide, please. So systems we have used are, the operating systems are, we have worked on our Windows and Mac. Languages we have used are Python and Prolog, uh, as defined, as also stated by others. And tools we have used are PyCharm, Prolog, Google Drive, and VS Code. And libraries we have used in Python for tokenization is PLY, and in Prolog we have used PySwift. Now I pass this presentation to Atharva for the demo of our project.
Hi, so this is Atharva Date. Let me shift to the language demo for our NAV language, and so I'll shift to the code base. Um, Guys, let me know if the screen is visible.
It's visible.
Yeah. So firstly, we start with the basic structure of our program, which is stored in the data file. So basically, we have a .nav extension for our programming language, as our language is named nav. And to start with, a simple Boolean file is what we refer to. And we have the main construct, which allows the main method uh, to declare declarations, construct commands, and basically have the output iterated to the print statement as well. So this is our basic program structure. Moving on to the first module of our project, which is basically the lexer, and we provide the source code with the .nav extension file to this particular lexer, and for that we use PLY library to generate out tokens, and also we define uh, regular expression rules basically for simple tokens to be generated. So what this lexer does is it basically takes in the source code as an input and delivers the um, single entity of the program as an output. So for example, if we see in Boolean, it would deliver the main separately and the colons and the Boolean and the values all together separately. So moving on to the next module, which is the parsing of the Lexer tokenization. And what this module would do is it would deliver a parse tree to us with the tokens that we have generated, which are used. So uh, this is basically what we do using the parsing structure, and we create a parse tree using DCG rules, which are explained by Nisha and Ansh earlier. So this is the parsing program. And finally, we have the evaluator where we get the parse tree from the parsing module. And basically, it prints whatever has been delivered in the print statement. Finally, moving to the executor part of things where we combine all the three modules, lexer, parser, and the evaluator. Um, so first of all, we read the input file to the executor program, and then we move our base to the lexer part, which takes in the input data, which is the .nav file, and converts it into the list of tokens as mentioned earlier. This list of tokens in this passed to a prologue program, which is parsing.pl, which has a program/3 evaluator, which takes in the list of tokens and delivers a parse tree. So for this, we particularly use the PySwip program, PySwip library, which is basically used for introducing Prolog in Python language. And once this is done, we evaluate our parse tree using the executor, using the evaluator Python file, which finally gives us the output on the command line. So everything is the everything is evaluated and like executed in the runtime module of our file. So I'm already in the runtime module of the code base, and where I would show demo for running basically a boolean.nav file, wherein we put in command python executor.py and the whole part directory of the file. So this would provide us true, since true or false is a true value. And moving on to the decrement program. So basically we have the boolean again. So executing the decrement program, we have the value 3. So yeah, that's it for the demo. Thank you.